a, like I said, pictorial depiction of the program. Okay, steps that are used in coding the LabView. Use LabView to acquire data from NI hardware during testing. Okay, this we have already gone through. This will need a VI, that is the virtual instrument, to capture data while testing using the NI hardware. Okay, so NI hardware, so for example, in most of the NVH applications, it will be NI9234. Okay, I don't know why this is.
You need to press the button.
Okay, so right, so this is NI9234. Okay, and DAC Assistant Express VI can be used to help you connect with a hardware and acquire signal or generate the signal accordingly. Okay, and there are many demos already available on the NI website. Again, we can go through that if if you need it. Please, you can request. We'll go through all the videos and we'll generate all those for you if you want. So the DAC assistant generates a TDMS file. Like I said, the TDMS is again like a very specialized format that has been generated by Labview scientists, and those people have already patented this. See, why is the need to go for this TDMS format? Can you explain? See, the need to go for TDMS format is that the data that you are streaming continuously through your NI9234 device, that is a very high resolution data. So suppose the data that you are streaming is normally to the range of 51 kilosamples per second. Okay, so that means you are streaming about 50,000 data points per second. Okay, and just imagine if you are just simply streaming this data for 1 minute. Okay, let's say 1 minute is a very short time to collect data. Okay, so 1 minute is equals to 60 seconds. Okay, so the amount of data points that you will get in this is 50,000 into 60. Okay, so that will be what, about 30. So this will be about 3 million and beyond that. Okay, and what I want to say is that in 1 minute you are getting so much of the data. Now how are you going to process this data? So in order to process this data, normally some kind of ASCII format can be used, and so for that purpose, you will basically be using some kind of TDMS format. Okay, so this is like, I will say, some kind of coded format which stores the data in a very concise manner. Okay, and now remember, you are doing this real time everything. Okay, so once you're doing this real time, again, all the information that you get, that needs to be channelized accordingly with a very short duration of time. Okay, and in a very concise manner. So that's why this TDMS file format is available. So this file can be read by LabView, and now you can also export this to something like MATLAB for that matter. Like even in MATLAB you can read the TDMS files. We have done it previously, and the data can be then processed accordingly. The file, you can open this file in Excel also, but mind you, in Excel at times the file will not open due to the number of lines, that are maximum number of lines that are available in the Excel, those will be finished, because the data is so much, like I said, that it's very difficult to store all that data and even open that in Excel. So some of the programming basics that we will be covering today, and we have this is the input and output files from the files generated by Labview and Excel files. We'll be showing how input output you can generate from Labview and then store it in Excel files. Conditional execution of the code, so how you can execute the code conditionally, and then something like debugging of the code, error handling. Okay, so all those things we will be covering, how to generate the report, how to run the code in sequence, a repetition of the code, loops, everything. So all these things we will be covering in this presentation. So let's look at the input output handling. There are many options in LabVIEW. The ones that we use is, like I said previously, the TDMS file format. That is what we will be using mostly. Okay, so the TDMS, open, write, read, close. There are many options in TDMS, and when we go through the example, you will have better perspective of what we are trying to do here. See, the purpose of this presentation is not to dissect the lab view in great detail, but to use lab view for our purpose, like to get the data from vibration data or noise acoustics data, and then use it further for processing. So opening the TDMS file, you can use this block, okay? And again, there are various inputs that need to be given, and the file output you will get in the TDMS file format, okay? The TDMS opens this, open VI can be used, and it helps to open a TDMS file. The file path is required input for this VI. Okay, the output TDMS file out is the file reference of the file on which the operation of the open is performed. Now, reading the TDMS file, if you see, the VI reads the TDMS file which can be opened, okay, and then it will need the group name and channel name to be read. So for example, now what will happen is, let's say you are testing a bearing, okay, and this is in continuous operation. Okay, now for this type of bearing you are using two different sensors. Okay, one is your accelerometer and the other is, let's say, a microphone. Okay, now these two sensors, they are connected to your NI9234 device. Okay, and they are connected to your NI9234 device, and then you are streaming this TDMS file to your computer through the TDMS block that we just saw. Okay, and the problem with this now is that how it will know whether this is a microphone data or accelerometer data, okay, and so on. So for that, you can simply use this channel or the group option that is available in the TDMS file. Okay, so the channel will help you to understand which data it is. Say, let's say whether this is microphone data or accelerometer data, or whatever other sensor that you are using. The group, now what is a group? Basically, see, what happens is, once you have collected the data, okay, let's say for 1 minute, okay, with some kind of radial load that is given here. All right, now if you want to carry out the similar operation, say 5 different times, okay, for 1 minute you are doing the same, you are performing the same test 5 different times. Now if you want to store that data in the same file, then you can group it as a different name. Okay, so then the group name will be 1, 2, 3, 4, and 5. Okay, so that's where the group comes into the picture. And as well, on top of that, you will see microphone and accelerometer data output as well. Okay, so these are some of the important things that are needed for the TDMS file. The channel name is the name of the sensor whose data you want to access. Okay, the group name is the name of the test you have performed. So number of times you are performing the test, that will be the name of that. Now list contents function, that is in the TDMS. Okay, so it will list out all the group names and all the channel names that will be needed. And let's look at the example now. So here's an example where you have collected the data from the accelerometer, okay, and you have taken the FFT of this data. This is the frequency spectrum that you are seeing. Okay, this is the accelerometer data that you are collecting. You have already performed the FFT operation on this, and this is the frequency response you are seeing now. Or you can also look at the octave spectrum. Okay, now how all this can be done in this, that we'll be looking at. You can analyze this file offline. Like I said, you can do a lot of different things in LabView offline as well as real time. Okay, in offline you can definitely look at different group names like file number 1, 2, 3, 4, 5, whatever, and then the channel, say microphone or accelerometer, whichever channel you want to analyze. And then you can also perform different statistical analysis of this, like RMS, mode, mean, median, kurtosis, and so on. Okay, and then important thing is you can also export this the whole data out here. Okay, whatever data you get, you can directly export in the form of Excel sheet. So this will be the front panel. Basically, this is how the front panel will look like. And the block diagram, again I'll show you the block diagram. So this is the block diagram, not the whole one, just we are showing the part where the TDMS file is there and the TDMS blocks are used. Okay, now the file to be analyzed, you have to give the path to that. Okay, this will be the path, and then it will open the TDMS file. It will list the contents for the group and again list the contents for the channel name. Okay, and then it will read the file. Okay. Now, once you read the file, then this file can be further analyzed using the FFT spectrum. Okay, this filter is basically an anti-aliasing filter. You can use different type of filter settings also, whichever filter you want to use for your data. And this is the FFT spectrum magnitude and phase VI. Like I said, in LabView there are many already established subroutines. Those are called as VIs. You can use those directly. The output is then the output of this you can see in the form of the plot. So this will be the graph or the plot you see of the FFT accelerometer. Okay, this plot that we just saw, this plot is basically the FFT accelerometer, right? And you can also observe this in the octave band format. Okay, now there are different blocks available to perform mathematical computation, statistical analysis. These are the different blocks like RMS, mode, mean, median, okay, kurtosis, and all these. Then you can save it in a tabular format. Okay. So these are the results that you will then see. So this is the whole idea of how a simple program can be built in LabView, and then it can be analyzed. You can look at the data, you can look at the numbers, and you can then say that okay, this is a defective bearing, or whatever part you are trying to analyze. That's how it will work. Okay, this is exporting the data in Excel sheet. This is what happens behind the scenes. Report generation is a big area in LabView, and you can customize your report according to the need, and or whatever, however you need, you can report the data accordingly, and that's how it will look basically. There are many report generation VIs that are available. Soon we will be making videos on how you can generate different reports, okay, in the Word format or in the Excel format. In detail, we'll be explaining all those. Okay, you can append the table to the report. You can do whole lot of different things in this. Basically, you can save this file. You can save the VI. You can dispose the report. Okay, all this we will be covering in detail in the next set of videos. Okay, and so I think we will end here. The debugging part and the other things we'll be covering in the next videos. So thank you so much for watching this. Please do like, subscribe to our channel, and share it with all the engineers out there who want to use this, and let's spread this to the NVH community. Thank you so much.